So let's start today's session on Introduction to Lean Manufacturing. So today I will cover history, definition, benefits of a lean manufacturing system, 3 M's of a lean, laying out lean manufacturing facility and 5 steps of a lean implementation. So let's start with a brief history on a lean manufacturing system. So lean manufacturing system or a lean production was first introduced by Womack, Daniel Jones and Daniel Rose book in Machine That Changed the World in 1991. The first person to truly integrate entire production process was Henry Ford. At Highfield Park, Michigan in 1913, he married constantly interchangeable parts with standard work and moving conveyance to create what he called flow production. So Henry Ford was the first person to introduce flow production in a manufacturing industry. The public grasps this dramatic form of moving assembly line, but from the standpoint of an engineer, the breakthrough actually went much further. As Kiichiro Toyoda and Taiichi Ohno and others at Toyota looked at this situation in 1930 and more intensely just after World War II, it occurred to them that a series of simple innovations might make it more possible to provide both continuity in process flow and a wide variety in product offering. They therefore revisited Ford's original thinking and invented the Toyota Production System, the TPS. So, what is lean manufacturing? So, lean manufacturing has defined in many different ways. So, one of the definitions given by MEP Lean Network is a systematic approach to identifying and eliminating waste through continuous improvement by flowing the product at the pull of the customer in pursuit of a perfection. So I highlighted 3 words to identifying and eliminating waste. It means non-value added activities in product and process part. And the second part I highlighted continuous improvement. It says that continuous feedback and improvement is needed in the product process part of a manufacturing industry. The third part I highlighted is the pull part. It defines that the customer feedback is important in lean manufacturing system. Let's now, what are the benefits of a lean manufacturing? Lean manufacturing delivers an insurmountable competitive advantage over competitors who do not use it effectively. So what are the advantages gained by the industry? The first is the lower production cost directly proportional to the higher profit and wages. Indeed, lean manufacturing reduces the production cost and directly increase the profit and wages of a company. It defines that the cost avoidance flows directly to the bottom line of the industry. Third is that supports ISO 14001 and a green manufacturing. So it defines that the reduction of a material waste and associated disposable cost directly proportional to the higher profits of an industry. Fourth one is that shorter cycle times. It definitely decreases the cycle time of make to order versus make to stock. Now, I will cover 3 M's of a lean manufacturing system. The first M, Muda, the Japanese word for waste. The second M, Mura, the Japanese word for inconsistency. The third M, Muri, the Japanese word for unreasonableness. Muda. Muda specifically focuses on activities to be eliminated. Muda, as defined in Japanese, is waste. Waste is broadly defined as anything that adds cost to the product without adding value to it. Generally, Muda can be grouped into following categories: excess production, early production, delays, movement and transport, poor process design, inventory, inefficient performance of a processes, making defective items. 7 types of waste or 7 types of Muda. The first is correction, repair or rework. Motion, any wasted motion to pick up parts or stack parts, also wasted walking. Overproduction, producing more than is needed before it is needed. Conveyance, wasted effort to transport material, parts or finished good into or out of storage or between processes. Inventory, maintaining excess inventory of raw materials, parts in process or finished goods. Processing, doing more work than is necessary. Waiting, any non-work time, waiting for tools, supply part, etc. 7 forms of waste or 7 forms of Muda is covered in this figure. In detail, I will discuss in later part of a session. The second M is Mura. Mura means inconsistency in Japanese language. Inconsistency is a problem that increases the variability of a manufacturing. Mora is evidence in all manufacturing activities ranging from processing to material handling to engineering to management. As it's shown in figure, inconsistency process output, inconsistency result. Consistent process output, desired result. Lean helps in consistent process and it gives desired output. Henry Ford, Today and Tomorrow in 1926, describe about standards. He says, to standardize a method is to choose out of the many methods the best one and use it. Standardization means nothing unless it means standardizing upward. Today's standardization, instead of being a barricade against improvement, is the necessary foundation on which tomorrow's improvement will be based. If you think of a standardization as the best that you know today but which is to be improved tomorrow, you get somewhere. But if you think of a standard as confined, then progress stops. So Henry Ford described about standards in Today and Tomorrow in 1926. The final M is for Mori or unreasonableness. Mores applies to variety of manufacturing and management activities. It is unreasonable to blame rather than mitigate issues. This is true for all manufacturing activities. Do what is reasonable. Don't be emotional. This figure shows the new paradigm, non-blaming culture. Management creates a culture where problems are recognized as opportunity. It's okay to make legitimate mistakes. Problems are exposed because of increased trust. People are not problems, they are problem solvers. Emphasis is placed on finding solution instead of who did it. Now I cover laying out a lean production facility. So I will talk on production facility layout. Another critical aspect of lean is organization of the production facility. Since one of the key to lean is waste elimination. Layout of any system should be arranged in such a manner that waste of motion, that is material handling and material transport, and elimination of inventory is a part of the object for the layout. There are two traditional forms of a layout in manufacturing, process and product. In a process layout or a job shop, as it informally called, machines are organized and clustered by type, where typically all mills are in one department or lathes in another. In a product layout or a flow shop, machines are located so that sequential operations are performed at adjacent machines. Advantages of a process layout are the flexibility of the system to product almost any part that fits within the volumetric boundaries of the machine. An in-depth understanding of a specific process can be obtained. Some tooling and fixture can be shared. Disadvantages of a process layout are spaghetti flow is difficult to manage and control. There is usually lot of inventory in front of each machine. Setup is usually expensive. Material handling times are large and it is difficult to automate this type of system. As shown in this figure, a typical process of a job shop layout. It shows the one mills in a one department, one lathe machine in another department. So different department has a same machine and its process is zigzag as mentioned earlier in the disadvantages. Now advantages of a product layout are large batches can be produced inexpensively, material handling is minimum, in-process material are minimized, it is easy to control this system, and automation is more achievable and justifiable. Disadvantages of a product layout are they are inflexible in that only one or very few products can be produced on them. Setup time for this system is very large. Duplicate tooling is required to replace worn tooling so that maintenance can be minimized. This is the layout of a typical product of flow shop layout. In this, the machines are arranged according to the process of a product. As the figure shows, lathe and mills, then drilling machine, grinding and assembly, and this assembly and shipping. It is one of the raw material received here in lathe, then is go to mill, grind and it assemble. So it is designed based on the process part of the product. Now there's another layout which is a hybrid of the product and process layout called cellular layout. Cells are used to make families of parts rather than just one of kind or high volume item. Cells are a logical cluster of machine organized to produce a variety of parts requiring the same equipment type, tooling and fixtures. Cells are intended to provide as many of the benefit of process product layout as possible. In many ways, cellular layout separates and group products within a manufacturing system into smaller units. As shown in this figure, there are three cells. First cells cover four machines: drilling, mills, and first cells cover drilling, lathe mills. So it is a hybrid version of product and process layout. Mostly today industry are using this hybrid layout.